Wow, I was done with number 11, about to do 15 before I realized I did not hit record again. Sorry, guys. So, let's explain number 10. I'm sorry, number 9 all over again. So, number 9 says the regular polygon below has a radius of 8 inches. Find the area of the polygon. Since it's a regular polygon, the area formula is 1 half a times p. In order to be a regular polygon, the figure has to have congruent sides and congruent angles. So that means this four-sided figure has to be a square in order to meet those qualifications. So I could also use the formula for the area of a square, which is a equals side squared. However, I don't know the length of my side. But what I do have is a portion of a diagonal. And so since I remember from earlier this year that a square is also always going to be a rhombus, I could use that formula also. The formula for the rhombus is area is equal to 1 half diagonal 1 times diagonal 2. So on this particular problem, the third equation would be my best bet. Again, I could use any one of the top two, but they would just take a long while to complete. You'd eventually get the same answer, so why not cut some of your time in half? And as you can see, when I worked this problem out in class for many of you, it took a while. A lot of y'all started to, get frustrated or confused. So if you can remember that a square is a rhombus, then just use the third formula. So they gave me a part of the diagonal, labeled it 8. And so if I were to extend it, it'd be 8 on the other side, giving it a total of 16. And since, again, I remember a square is not only a rhombus, but it's always a rectangle, my diagonals will equal. So that means the other diagonal has to be 16 as well. So, no, it's not any harder now. Just simply put the diagonals in place, multiply them together, divide them by 2. When that is done in the calculator properly, you should get 128 inches squared. Now on number 13. It says points R and W are on KN, so it's probably best that you draw this out, KN, and then put W and R in the appropriate places. R has to be between N and W, so I have done that. Then it lists out the measurements of certain pieces. It tells us the distance from R to N is 6, and the distance from K to W is 10, and the entire distance of the line is 24. If a point on KN is chosen at random, what is the probability that the point is on RW? So here's another probability question. And again, all your probability questions, you have to have your desired portion over your total portion. In this case, our desired portion is anywhere between W and R. So we need to find that length. Since we know that KW is 10 and RW is 6, together that makes 16. And then if you take that away from 24, you would end up with 8. And so 8 is the length from W to R. And which is also our desired area. So that's going in the numerator of our probability fraction. The total line distance is 24. So that's going at the denominator of our probability fraction. And then the question had asked for us to express it in lowest terms. So that means A, put it in your calculator, 8 divided by 24, and it'll give you a decimal. So then you're going to have to turn it back into a fraction. That's one way to find it. An alternative way is to use your knowledge of numbers. You know that 8 goes into itself and it goes into 24. So 8 goes into itself. one time. 8 goes into 24 3 times. So if I divide 8 from both the top and the bottom, I'll be left with 1 over 3. So that's the fraction in lowest terms. And number 10. For number 10, the things to remember is that this is a square prism, so the base is the square portion of the solid. Then I got to make up whatever numbers I wanted. You could do the same, and you would get different volumes than I did, and that's totally fine. But at the end of the day, our final answer will definitely be the same. So when this question says, if the sides of the base of the square prism are multiplied by 5 and the height of the prism doesn't change, what is the ratio of the new volume to the original volume? First of all, again, you need to give this figure some dimensions in order to calculate the volume. According to your formula chart, the volume can be found by taking big B times H. But again, since we remember that a square is technically a rectangle, you could use that other formula that's on your chart for the rectangular prism, which says just take your length times your width times your height. And that's exactly what I did. I used the second formula. So you do the same. So my original dimensions for my base were 1, and then for my height it was 2. So I took 1 times 1 times 2 to find the volume, and I got 2. Then the directions asked for us to change the size of the base to multiply them by 5. So every 1 on the base would now become a 5. And then it also told us to leave the height alone. So when I found the new volume, I multiplied 5 with 2. And I got 50. But that's not my final answer still, because it says what is the ratio of new to old. So when you write the ratio, new has to come first. So my new volume was 50. My old volume was 2. When I write it as a fraction in lowest terms, it would be 25 over 1. A ratio could be written using a colon as well. So that's the second one that you see. Or it could be written with the word 2, which is the third one I've displayed. So just be careful and don't be afraid. If you see one way versus the other, they all have the same meaning. As long as you put new first, then you're okay. Now we're on to number 14. Number 14 tells us that Holly has the following coins in her pocket: 7 pennies, 3 nickels, 5 dimes, and 6 quarters. If she randomly takes a coin out of her pocket, then without replacement takes another coin, what is the probability that she took out a dime and then a penny? Express your answer as a fraction in lowest terms. So we have another probability question. So we have 2 events going on. You pull one coin out of your pocket and then another coin. So our first probability is the probability the first pick is a dime. And then we're going to multiply that with the probability that the second pick is a penny, given that I've already picked a dime. And I didn't put it back. So on the first pick, I have a option to choose 5 dimes out of a total of 21 coins. On the second pick, I have an option of picking 7 pennies out of a total of 20 coins. It's now 20 because I didn't put the first coin back. So now put these 2 fractions in your calculator, multiply them, and write it in lowest terms. And in lowest terms, your answer should be 1 over 12. Number 11. If the radius of a sphere is multiplied by 6, how much larger would its surface area become? So again, I could use my own radius, find the surface area, and then multiply the radius by 6 and find the new surface area and compare the two. But there's a shortcut for that. If I want to know the new surface area, I would simply take the original surface area times the scale factor to the second power. So in this problem, our scale factor is 6. So 6 to the second power is 36. So I would be taking my original surface area and multiplying it by 36. So if that's the case, then that means my new surface area, will be 36 times larger. And it's just that simple. Number 15. A small business is going to lay off 5 of its 22 employees. The employees will be chosen randomly. What is the probability that the 5 oldest employees will be laid off? So there's 5 events happening. You lay off one employee, a second, a third, a fourth, and then a fifth. The first layoff, you have 5 old employees to choose from out of a total of 22. On the second one, you have 4 now out of a total of 21. And then 3 out of 20, 2 out of 19, and finally 1 out of 18. So to find this fraction in lowest terms, you need to multiply all these together. Now this problem in your calculator is a stinker. So we're going to have to work this by hand. So multiply straight across the top, you would get 120. And if you multiply straight across the bottom, I forgot what you get. Hold on one second. Let's do it together. 22 times 21 times 20 times 19 times 18. Woo, that's a long number. 316,080. Since there's a 0 on the end right away, I know I can divide it by 10, which would knock it down to 12 over 316,008. And this is an example on how you reduce a fraction. At the top, I have 12. I know that's divisible by 4. So I can divide it by 4. And I can divide the bottom also by 4. And when I do that, I would get 3 over, I'm sorry, I never divided it by 10. 3 over 7, 9. And then I recognize that both of these numbers are divisible by 3. So this would become 1. And this would end up becoming 26,334. That's the final answer in lowest terms. So you see, even Miss Perry can demonstrate how to properly reduce a fraction. And that's the steps you would have to take if your calculator is not behaving properly or as you think it should. Number 12 wants us to talk about cross sections. Now, a cross section is nothing but a plane cutting. Think of a plane as a knife cutting through a figure. In one slice, is this shape going to appear? Yes or no is what we have to answer. So the first one, and we're trying to see if a triangle is possible. So if I slice a triangular prism, yes, it's possible to get a triangle. If I slice a pyramid, yes, it is possible to get a triangle. If I slice a cylinder, no, it's not possible to get a triangle. When I slice a cone, yes, it is possible. And when I slice a sphere, no, it is not possible any way, shape, or form to get a triangle. And last but not least, number 16. A pet store has 9 puppies. One puppy will be placed by the front door. One puppy will be by the cash register. One puppy will be chosen as pet of the week. How many different ways could 9 puppies be selected in this manner? So this is no longer a probability question. It's asking how many different ways. And on this case, order doesn't matter. So if order doesn't matter, it is a combination. So it doesn't matter that one puppy's chosen first, second, or third, or first, third, second. That doesn't matter. Just count them how you see them and only count them once. So in our calculators, we're going to go and find NCR, which stands for the combination function. Since we have a total of 9 puppies, N will be replaced with 9. And since we want groups of 3, we're going to replace R with 3. And the calculator will tell us just how many groups possible that is. To find it, you would go to math, probability, and choose option 3. I forget my calculator on my screen is older than the ones in the classroom. So, in the classroom, you won't have any problems. But for me, I got to type 9 first, then go back to math, probability, 3, and then type my 3. And I get 84. So on yours, you're going to have boxes for the 9 and the 3 and hit enter. You should be fine. So there's 84 possible ways to take care of this. There's 84 possible ways to group these 9 puppies and have 84 totally different groups of 3. On to the packet. I'm going to skip questions 1 through 16 because, again, they're almost identical to these first set we've had. Let's jump over to number 17. Give me a moment. Again, we're going to start with number 17 as 1 through 16 are duplicates of the first part. So number 17 wants us to convert 120 degrees to radians. To do that, we're going to take 120 times pi over 180, which is the conversion factor. And we're going to leave it in terms of pi. So that's essentially 120 pi over 180. And when you reduce it to lowest terms in your calculator without pi, you would get 2 over 3 pi radians. That's RAD, radian. Now, number 18 wants us to convert 5 over 7 pi radians to degrees. So we're going backwards. So 5 over 7 pi is technically at the numerator. And now we're going to multiply it with 180 over pi. So if you want the degrees to turn to radians, pi has to be on top. If you want the radian to turn to degrees, pi is on the bottom. And now, again, you're multiplying it. When you multiply, the pi's will cancel. And your calculator as a fraction will give you 900 and over 7 degrees. But as a decimal, it's approximately 128.6 degrees. The decimal is a nasty decimal, so that's why I showed you both the correct fraction and the decimal. Number 19 wants you to name the polygon. So first of all, let's start off with how many sides it has. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since it has 10 sides, it's a decagon. And since some of the sides are pointing inward towards the figure, we call it a concave decagon. You can answer number 20 on your own. Just look directly from your notes on that lesson. Let's go to 21. Find the surface area of the prism below. This is a rectangular prism, and they want the surface area, which can be found by the formula pH plus 2b. So let's say B is the top of the box. Okay. P stands for perimeter. So to find the perimeter of my base, I'm going to take 2 times 7 plus 3, which is 2 times 10, or 20. My height, my 3D height is 4. And then big B is the area of the base, so that's 7 times 3, which is equal to 21. Now we put everything in their place like we did on the Unit 12 test. So we put 20 here, 4, and 21, and then put it in the calculator. You would get 122 inches squared. Number 22 also wants the surface area, and it's still a prism. So the formula hasn't changed. So it's equal to pH plus 2b. So again, the top is going to be my base. So to find the perimeter, it's going to equal 2 times 15 plus 8, which is 2 times 23, and that gives you 46. My 3D height is 10, and the area of my base is found by 15 times 8, which would give me 120. So again, put everything where it belongs. Forty-six, 10, 120, and you get 700 inches squared. Now, number 23 says, if the prism in number 21 is placed on top of a prism in number 22, what would be the surface area of the result composite? Now, when we taught this, nobody liked it, but it's true. One easy way of doing it is to take the surface area of each one, so surface area of 21 plus the surface area of 22, but then you must subtract the joining surface, the area that is shared by both, and you must take it out twice. So when you look back up at the figures, 21 is smaller, and so when it sits on top of 22, the area that's going, the only portion that's going to be shared is the base portion of the smaller one, which is this little shaded area here. So I'm going to take away 2 of the bases from the smaller one. So remember that. So again, 2 bases from number 21. So the surface area for 21, again, was 122. The surface area for 22 was 700. And then I'm going to take away 2 of the bases from 21. The bases from 21 were 21. And after putting all of this into the calculator, you should get 780 inches squared. And this concludes your tutorial over the final exam review. Finish the rest of the problems on your own. Remember to turn this in on the day of the final for potential extra credit points. Good luck to you.